Problem number 1. If 6.60 moles of H2 are made to react with 4.42 moles of N2, what is the limiting reagent? How many moles of NH3 will be produced? What reagent is in excess and by how much? Determine which reagent will produce the smallest amount of products, and the actual yield of NH3 is 65.5 grams of NH3. In problem number 1, we are tasked to find the limiting reagent, and then we are going to find the number of moles of NH3 to produce, and then the reagent or the excess. Sometimes or mostly the theoretical yield is also same with the excess reagent. And then we are tasked to find or to determine what would be the smallest amount of NH3 to be yield if the actual yield is 65.5 grams of NH3. So the problem gives us the formula of H2 plus N2 will yield NH3. But as we can see, the equation is not balanced. So first thing we should do is to balance this equation. In our reactants, we have hydrogen and nitrogen. In the product, we have hydrogen and nitrogen. Please count the number of atoms. Here is 2, H is 3, N is 1. So what will be the coefficient needed to balance this equation? So we will put 3 here, and we will put 2 here in NH3. So now the hydrogen will become 6, and then nitrogen here in the product will become 2 because we will distribute the coefficient 2, and the hydrogen 3 times 2 will become 6. So now we have a balanced equation. So it is important to us to balance the equation for us to find the ratio. So therefore, in every 3 H2 we will have 2 NH3, and in every 1 N2 we have 2 NH3. The ratio is important in solving the limiting and excess reagent. Okay, so let's start finding the limiting and excess reagent. Okay, so first let's solve for the H2. According to the problem, we have 6.60 mole of H2. So again, what is the ratio of H2 to our product, which is NH3? Okay, so the ratio is in every 3 mole of H2 we have 2 moles of NH3. So we now cancel H2, therefore we now have the product of NH3, and then 6.60 times 2 divide 3, that will be 4.4 mole of NH3. Okay, so this is the number of mole we will produce if we will be using 6.60 moles of H2. So let's solve for the N2. According to the problem, we have 4.42 mole of N2. So again, what is the ratio of N2 to our product, which is NH3? it is in every 1 mole of N2, we have 2 mole of NH3. Cancel the mole of N2. So 4.42 times 2 divide 1. The answer is 8.84 mole of NH3. So this will be the product. If we will be using 4.42 moles of N2, the product of NH3 will be 8.84 mole of NH3. So as we can analyze to the product, we can say that this is the limiting reagent, H2. Why? Because it will be the first one to diminish in the chemical reaction. So 8.84. So therefore, N2 will be the excess reagent. So as we can analyze in our solution, we now have the value of NH3 if we will use the designated amount of N2 and H2. So we have the smallest number of NH3, which is 4.4 mole. So therefore, H2 will be our limiting reagent. So H2 will be limiting reagent because if this equation or chemical equation happen, H2 will be the first one to diminish, while our 8.84 mole of NH3, which is the largest amount of NH3 or the product that indicates with the use of 4.42 mole of N2, will be our excess reagent. Okay, so here in the solution, we can now say that the product of limiting reagent is our theoretical yield. So this will be our theoretical yield. So now we will answer the last question, which is finding the percentage yield of the chemical equation if the actual yield is 65.5 grams of NH3. So from our previous solution, we now found D. So now we will convert the theoretical yield into grams, because in solving the percentage yield, we must use the unit of grams. So we have here 4.4 mole of NH3. So let's recall, how are we going to convert that? First, we must find the molar mass of NH3. Okay, so N is 1, H of 3, multiply by their atomic mass. Atomic mass of nitrogen is 14, and atomic mass of hydrogen is 1. So 14 and then 3. 14 plus 3 is 17 grams of NH3. We now have the molar mass of NH3, which is 17 grams of NH3 and 1 mole of NH3. So cancel the mole. 4.4 moles times 17 divide 1. We have 74.8 grams of NH3. So now we can now compute the percentage yield. Okay, so the percentage yield is equal to the actual yield over theoretical yield multiplied by 100%. Okay, so according to our problem, our actual yield is 65.5 grams of NH3, and our theoretical yield in grams is 74.8 grams of NH3 multiplied by 100. So the percentage yield of our chemical equation is 87.57%. Okay, so let's recall our answer. So here in our problem, we are tasked to find the excess, limiting, theoretical, and the percentage yield. Okay, so our excess reagent is 8.84 moles of NH3, which can be produced only by N2. So our excess reagent is N2, and then the largest amount to be produced in a chemical equation using this N2 will be 8.84 mole of NH3. Next one is the limiting. So in solving, we come up with 4.4 mole of NH3 that can be produced using the H2. So our limiting reagent is H2. In using the H2 in a chemical equation, we can have the smallest number or amount of product, which is 4.4 mole of NH3. And in the same time, this 4 mole of NH3 is our theoretical yield. If we convert the theoretical yield, we have 74.8 grams of NH3, and that is equal to 4.4 mole of NH3. Therefore, using the theoretical and actual yield, we can have the percentage yield, which is 87.57%. So now we answered the problem number 1. Problem number 2. 2 moles of propane reacts with 8 moles of oxygen in a combustion reaction. How many moles of carbon dioxide are formed, and how much of the excess reaction is left over with 4.6 moles of the actual yield? So here in problem number 2, we are going to find the excess and limiting reagent as well as the percentage yield, because we have a given actual yield, and we are going to find how much is the excess or the leftover in our excess reaction. In problem number 2, we can have a chemical formula of C3H8, which is the propane, and then it will react in an oxygen, will yield a carbon dioxide and H2O. So first thing we should do is to balance the equation. First, in balancing the equation, we must list down the elements in reactants and product. So we have carbon, hydrogen, oxygen, carbon, hydrogen, and oxygen. So here we have 3 carbon, 8 hydrogen, 2 oxygen, 1 carbon, 2 hydrogen, 3 oxygen. What are the coefficients we need to add to balance this equation? First, we must put 5 here, 3 in carbon dioxide, and 4 in H2O. So therefore, the value or the amount of atomic number in carbon will be 3, oxygen will be 3, 6, and then 7, 3, 6. Okay, so 3, 6 plus 4, it will become 10. And then the hydrogen will be 4 times 2 is 8. Here, so balance the oxygen. So 5 times 2 is 10. So therefore, we now have a ratio. We have 1 propane and 5 oxygen in every 3 carbon dioxide. So in every 1 C3H8, we have 3 carbon dioxide. In every 5 oxygen, we have 3 carbon dioxide. There is an easy way in finding the limiting and excess reagent. So the simplest way to determine the limiting and excess is by their own mole. So for example, since we know their ratio, so in every 2 mole of propane, so this 2 mole came from the problem, we have 1 mole of C3H8, which came from this chemical equation balancing, and then 2 divided 1 is 2. Next is the oxygen. Oxygen have 8 mole from the given O2, and in our balance equation we have 5 mole of O2. The answer is 5 divided 8 is 1.6. Okay, so simply we can say that 2 is the excess reagent. So 2 is the least known. So we can say that 2 is the excess reagent and 1.6 is the limiting. So therefore, the excess reagent is propane, and then the limiting reagent is the oxygen. Why? Because oxygen is only 1.6 and propane is 2. This is the simplest way in finding the limiting and excess reagent. So let's try to solve it from our old ways in finding the limiting and excess reagent. So let's start with propane. So from the problem, we have 2 mole of C3H8, which is the propane. So again, what is the ratio of propane to carbon dioxide? Especially class, please take note, we only are going to solve for the carbon dioxide, not in the H2O, because that is in the problem. Okay, so in every 1 mole of C3H8, we have 3 mole of carbon dioxide. That will be 2 times 3 divided 1. That will be 6 mole of carbon dioxide, because we will now cancel the propane. Okay, so let's solve for the oxygen. So oxygen is 8 mole according to the given. Multiply what is the ratio of oxygen to carbon dioxide? So in every 5 mole of oxygen, we have 3 mole of carbon dioxide. So 8 times 3 divide 5, that is 4.8 mole of carbon dioxide. So cancel lang yung mole of oxygen. So now we can say that if we use 2 mole of propane, we can have the 6 mole of carbon dioxide, which is a large amount compared to 4.8 mole of carbon dioxide. So therefore, this is the excess and this is the limiting. Why? Because in a chemical reaction, oxygen will be the first one to diminish once the chemical reaction take upon. And the only amount of carbon dioxide that can be produced if we use 8 mole of oxygen is only 4.8 mole of carbon dioxide. And therefore, this 4.8 mole of carbon dioxide is our theoretical yield. Okay, so now we are done finding the excess. So the excess reagent is propane. The large amount that can be produced using the propane is 6 mole, and our limiting reagent is oxygen. So oxygen can produce the least amount of the product, which is 4.8 mole of carbon dioxide. Okay, so we are going to find the percentage yield. So as you can see, our actual yield is in mole. So therefore, we will be using the unit of mole. Okay? In finding the percentage yield is equal to the number of actual yield over theoretical yield multiplied by 100%. Okay, so according to our given, the actual yield is 4.5 mole. And our limiting reagent, which is also the theoretical yield, is 4.8 mole. So therefore, in solving that, 4.5 divide 4.8 times 100, the percentage yield is 93.75%. Okay, so that is the answer. Next, or the last one, is we are tasked to find the excess in the reactants, or the leftover in our excess reagent. So how are we going to find that? We will just minus the total to the amounts of propane reacts in a chemical reaction, and that will be our leftover in excess. Okay, so for the last question, we are tasked to find the leftover in the excess reactant. So we are just simply finding the total amount of the leftover. Okay, so the total amount of the excess reagent is 2 mole of propane. So that is the excess in a chemical equation. But how are we going to find the amount that is used in the chemical equation? So let's start by 8 mole of O2. So what is the ratio of oxygen and propane? So in every 5 mole of O2, we have 1 mole of C3H8 or the propane. Cancel. We have 1.6 mole of C3H8. So this 1.6 mole of propane is the total amount that is used in a chemical equation, or that is the total amount of propane reacts. Okay, so therefore 2 mole of propane minus 1.6 mole of propane, the answer is 0.4 mole of C3H8. So therefore, after the chemical reaction or the combustion of propane and oxygen, there is still excess. Okay, not all 2 mole of the propane is used, only 1.6. Okay, so the excess is 0.4 mole. Okay, so let's review our answer. So in problem number 2, we are tasked to find the excess, limiting, percentage yield, and then the leftover in excess. So our excess reagent is propane. Okay, so the excess reagent is C3H8. If we use the 2 moles of C3H8, we can have the large amount of product to be produced, and that is 6 mole of carbon dioxide. Next one is the limiting reagent. The limiting reagent is oxygen. Okay, why? Because that will be the first one to diminish once the reaction or the chemical reaction takes upon. So this O2 will limit the reaction, and if we use 8 mole of O2, we can have the least amount of the product, which is 4.8 mole of carbon dioxide. At the same time, this 4.8 mole of carbon dioxide is our theoretical yield. So using that 4.8 mole of carbon dioxide, we can compute the percentage yield by transposing the value of the given actual yield, and we have the percentage yield of 93.75%. Okay, and then the last question is we are tasked to find the leftover in excess, or once the excess reagent are used, what will be the amount or the total amount that is left over, and that is 0.4 mole of C3H8. Because it is excess, some are not used, so there are leftover. Okay, so as we can see, even though the number of our reactants are larger or smaller, it not determines if it is the reactants or limiting, because sometimes, as we can see, we only have 2 mole of C3H8, but it is an excess, while our oxygen have a large amount, which is 8 mole, and that will be the limiting reagent. So the number of mole or the number of mass of our reactants will not determine if there are excess or the limiting reagent.